In this video, we're going to take a look at linear functions and how we can use them to figure out some word problems. In a previous video, we worked with linear functions and linear equations. Now what we're going to do is look at word problems where the equation that we end up building is linear. Now, what this is mathematical modeling with linear equations. The idea of mathematical modeling is to create some sort of a mathematical expression that applies to a real situation. So we're going to do that with linear equations in this section. Now, there's probably a lot of different material that tells you step by step how to do a specific word problem, but I skip all of the step by step stuff because every word problem is different. However, if we're trying to figure out how to do a word problem or how to do an application problem, the basic steps are always the same. We have to understand what's going on with the problem. Then we have to create some sort of a mathematical equation or equations, and then use that equation or equations to answer some questions. Let's do that in example 1. Here we have this application or this word problem. It says an equipment leasing company charges $4,300 for a delivery charge plus $450 per day for an industrial mixer. Write an equation for the cost of the mixer after a certain number of days. We'll use C for the cost of the mixer and lowercase d for the number of days. And when we do this, we will be case sensitive. So when we write our equations, we'll always make sure that they have the right variables. Once we do that, then we'll ask how much would it cost to rent the mixer for 14 days. In this case, what we do is we're going to set up the linear equation. The leasing company charges a flat rate of $4,300 plus an additional $450 per day. So the total cost, which we're writing as C, is equal to that flat rate of 4,300 plus 450 per day. Whenever it says per day, we're thinking 450 times the number of days that we have rented this for. That is a linear equation in 2 variables. The variables are C and D. If you want to, it doesn't matter that the 4,300 came first or the 450 times D came second. You could have switched that up. And sometimes people like to write 450 times D plus 4,300 because that aligns with the slope-intercept form that we're used to. Now we can go and answer this question. How much would it cost to rent this mixer for 14 days? All I have to do is plug in 14 in for the D. Again, it doesn't matter which version of this you pick. I'll do the second version. So C is equal to 450 multiplied times 14 plus 4,300. That's something I can just type into my calculator to get the answer. And when I do that, I get a C, which is equal to 10,600. Now, this is a cost and everything was in dollars. So the cost to rent for 14 days is $10,600. That's how we would answer that question. So that's it. That's the entire problem from example one. We could create the equation, create the linear equation, because this essentially gives me the slope and the y-intercept directly. A lot of times I refer to this as a fixed plus variable cost. The fixed cost is the cost for the delivery, and the variable cost is the cost for the number of days we rent. So cost per day times number of days is a variable cost. The 4,300 is a fixed cost. Let's do another example. In example 2, it says an investor thinks there will be a linear relationship between the price of a particular stock and the number of years that he holds on to it. The stock was purchased for $15.25 in 2008 and was worth $19.09 in 2020. Let's assume that this investor is correct, meaning the relationship is going to be linear. Write an equation for the price of the stock T years after 2008. Once we do that, then we'll use that equation in two ways. One way is we'll ask how much would the stock be worth in 2050? And the other way, we'll ask when will a stock be worth $30? So in this one, we have to be very careful of the fact that we're talking about T years after 2008. So our starting year is going to be 2008. That makes a difference when I create my linear equation. So here's what we're going to do. We're going to set up a linear equation, and I'm going to put the price of the stock as P. That's going to kind of act as the Y value. And then I'm going to have a slope times the variable T. T is the number of years after 2008 plus B. So it's like Y equals MX plus B. P equals M times T plus B. Now, in this case, these two prices at that particular time create ordered pairs. Our ordered pairs are going to have the form T comma P. So I'm going to put the time comma P, but I have to be wary of what this T means. Remember, T is the number of years after 2008. So at year 2008, that is a time of 0. And at time of 0, I know the price was $15.25. That creates 1 point that I know goes through that line, or that the line goes through. In 2020, the price was 19.09. Now, be careful about this. 2020 has a t-value of 12 because that's the difference in time. Remember, a time of 2008 is a t-value of 0. So 2020 would be a t of 12. And the price 12 years after 2008 was $19.09. In order to find the slope, what I would do is my standard slope formula, the y value of 0.2 minus the y value of 0.1 divided by the x value of 0.2 minus the x value of 0.1. 19.09 minus 15.25 comes out as a 3.84. 12 minus 0 is just a 12. So when I divide that, I get 0.32 as my slope. Now, in this case, I know exactly what the B value is. I could also plug in either of these 2 points, but think about plugging in this first point. If you plug in a 0 for T and 15.25 for P, then the B is 15.25. In other words, that point is the y-intercept. So in this one, it gives us the B directly as 15.25. So when all said and done, the price of this stock is going to be 0.32 times the number of years after 2008 plus 15.25. And what this slope is essentially referencing is that every year the stock is growing, the price of the stock is growing by 32 cents. It started out at 15.25 and it's growing at a rate of about 32 cents per year. Once we have that equation, then we can use it to answer the other 2 questions. How much would the stock be worth in 2050? Well, 2050 is a t-value of 50 minus 8 is 42, so it's a t-value of 42. 42 years after 2008. So to find the price in 2050, we would write 0.32 multiplied times 42 plus 15.25. I type that into my calculator and it says that the price in 2050 should be, if this pattern keeps up, $28.69. Okay. And again, I'm just simplifying that. P equals, there we go. Now, when will the stock be worth $30? I'm going to take this same equation, and if we're asking when will the stock be worth $30, we're saying when is the price 30? In order to solve this, we would take 30 minus 15.25, and then I'd subtract 15.25 on the right-hand side as well. When I do that, I get 14.75 is equal to 0.32 times t. Then divide both sides by 0.32. When you divide both sides by 0.32, you get approximately 46.09 as the t value. Now, be careful about that. That does not mean that, well, let me start over. So be careful about that. That doesn't mean 2046. Remember, the T stands for time since 2008. So when we add this, we're talking about to 2008, we're talking about the year 2054, about the year 2454, or you can say year 2054.09, if that makes sense to you. So just a little bit after 2054. But again, be careful, T is time since 2008. That's how we can create and use a linear equation when I'm given essentially 2 points. And also this one shows that sometimes we're given our points in interesting ways, like having t be the number of years since 2008 rather than the t value just being the year. Let's look at another application problem. In this word problem, it says, a scientist sees a linear relationship between the number of scientific papers published at an institution and the number of grants the institution received. There were 345 papers published at institution A who received 86 grants, and there were 898 papers published at institution B who received 156 grants. Write an equation for the number of papers published, we'll call that P, when an institution receives G grants. Once we do that, we'll also answer these related questions. How many papers would be published if an institution received 40 grants? And then how many grants would an institution need if they wanted to publish 1,200 papers? If you want to push pause on the video and try this on your own, go ahead and do that. In a couple of seconds, I will show you how it's done. In this case, we're looking at papers published versus grants. I'm going to think of the grants as the inputs and the paper published as the outputs. So whenever I'm thinking of an ordered pair, I'm thinking of it as the grants and then comma, the papers published. When I create an equation, therefore, I'm probably going to write it as papers published equals some slope times the number of grants plus the intercept. Just like y equals mx plus b. Now, in this case, institution A had 345 papers published and received 86 grants. So we write 86, comma, 345 as my point. That's institution A, the point for institution A. For institution B, there were 898 papers published, and they received 156 grants. So with 156 grants, there were 898 papers published. Now, technically, you can reverse the roles of G and P. You would just get a different equation, a different looking equation. It would actually be algebraically equivalent to this one. Once again, we say, what is that slope? I use the slope formula, 898 minus 345. That's the y value of 0.2 minus the y value of 0.1. All of that is divided by the x value of 0.2 minus the x value of 0.1, which is 156 minus 86. Now, if you take 898 minus 345, you get 553. And 156 minus 86 gives you 70. That is a value of 7.9. I'm going to use the decimals. Sometimes if I don't get a nice decimal, I'll just use the, excuse me, I'll use the fraction. But in this case, I got a nice decimal that stopped, so I'll just use the decimal. Again, 156 minus 86 was 70. When I divide 553 by 70, I get 7.9. Now I know that the equation looks like this. P equals 7.9 multiplied times G plus some intercept. And this is where I can plug in one of these 2 points. Doesn't matter which one. I'll plug in the second point. So 898 is equal to 7.9 multiplied times 156 plus B. 7.9 times 156 comes out to 1,232.4. And therefore, in order to find B, I would subtract 1,232.4 from both sides. That gives us a negative 334.4 is equal to B. So the equation that I'm using, or that I should be using, is that P is equal to 7.9 times G minus 334.4. So let's look at this. How many papers would be published if an institution had 40 grants? I would take this equation. If the institution had 40 grants, I just have to replace the G with 40 and then simplify that. 7.9 times 40 minus 334.4 gives a negative 18.4. By the way, that should not make a whole lot of logical sense. And that sometimes can happen. So this is a demonstration of where the mathematical modeling gave me a scenario which doesn't make logical sense. You can't publish a negative number of papers. But that's perfectly all right. Sometimes the mathematical modeling does that. It gives you something that doesn't make a whole lot of sense. How many grants would an institution need to publish 1,200 papers? Well, we take 1,200 is equal to 7.9 times G minus 334.4. I'd add 334.4 to both sides. That would give me on the left-hand side 1,534.4. On the right-hand side, I'd get 7.9 times G. And then we divide both sides by 7.9. When dividing by 7.9, we get about 194.23 is equal to G. Now, this is what the mathematical model gives in each situation. In this situation, obviously you can't publish 0.23 of a paper, or maybe you could do some weird counting. Maybe you're one of 4 authors and that counts as a quarter of a paper. I don't know, but usually not. Usually you publish a whole number of papers. So, or, oh, I'm sorry, this was grants. So let's talk about grants. You wouldn't get 0.23 of a grant. Maybe you would. Maybe it's divided up. A single grant is divided up between institutions. But in reality, we'd probably say you would expect that you would need about 194 grants in order to publish 1,200 papers. So somewhere in the range of 194, 195. What I usually do is I just leave it as a rounded number, and people can understand that usually. So 194.23 grants are needed to publish 1,200 papers, even though you might say 0.23 of a grant doesn't exist. And the same is true here. If I had to interpret this, I would probably just leave it as is. I would state that with 40 grants, the institution would publish negative 18.4 papers. Some people wouldn't like that answer, and they'd say actually they'd publish 0 papers because technically 0 is the minimum. But oftentimes I might even use that negative there. Okay, so just look at what the question asks for the end result. If it's asking for something that has to make logical sense, then we'd say publish 0 papers. If it just is asking for the output of this formula, then negative 18.4 would work. Again, down here, if it asks for something that has to make logical sense, then we'd say 194 or 195 grants are needed to publish 1,200. But if it just asks for what the output or the input of the function needs to be, the input of the function needs to be 194.23. Hopefully that makes sense. Let's do another example. Let's say there is a city whose population is growing linearly. It had 20,132 people in 2005 and had 34,114 people in 2022. Let's write an equation for the population of the city T years after 2005. So in this case, T stands for the number of years after 2005. And then once we know that, we'll answer 2 questions. Using this model, what will the population of the city be in 2030 if this pattern continues? Also, using this model, in what year would you expect the population to be 50,000? If you want, go ahead and push pause on the video and try this example on your own. In a couple of seconds, I will do it on the computer. In this case, T is the number of years after 2005. So it says the city had 20,132 people in 2005. So that's like year 0. Maybe I should say this. I'm thinking of this as T comma P. So T is my input, P is my output. And if we do that, having 20,132 people in 2005 corresponds to a point of 0, 20,132. In 2022, having 34,114 people corresponds to the point 17, comma 34,114. Notice that the T there was 17 because 2022 is 17 years after 2005. I want to create the equation. Again, we're just using different variables. P is equal to M, that is the slope, times T plus B. The slope there is going to be given by 34,114 minus 20,132 divided by 17 minus 0. That's the slope formula. When you take 34,114 minus 20,132, you get 13,982. And we're dividing that by 17. If you divide this by 17, you get kind of a nasty decimal. So I'm going to leave my slope as that fraction. Even though it's kind of an ugly looking fraction, I'm going to leave it as that fraction. Now I know that my formula should look like P equals 13,982 over 17 times T plus B. And since we know the line goes through the point 0, 20,132, when I plug in a 0 for T, my B value has to be 20,132. This is the equation in this scenario. P is equal to, again, this ugly fraction of 13,982 over 17 times T plus 20,132. Then we can ask, what will the population of the city be in 2030 if this pattern continues? 2030 is 25 years beyond 2005. So we take 2030 minus 2005, and that's a T of 15. Oh, sorry, 25. Hit the wrong button there. So T is equal to 25. 2030 is 25 years after 2005. And then plug that in. This is saying that the population will be 13,982 divided by 17. And then I multiply that by 25 and add 20,132. So let's do that simplification. I ended up with 40,693.76. Now, again, population can't be a decimal technically with logic. Sometimes people will be very strict about getting the right type of answer. Other times people will be less strict and they'll say round any answer to 2 decimal places. So if people aren't strict about being precise, about being logically doable, they would say, well, the population will be 40,693.76. If somebody says, well, let's be really strict because the population is forced to be a whole number, they'd say the population will be 40,694. Either way, Either way is okay. In this video, it kind of just depends on how your instructor will want that. The actual valid population you could be, or the output of the model. The output of the model, 40,693.76, or a valid population that you could achieve, which is 40,694. By the way, before I move on, I forgot to mention earlier that this number, 13,982 divided by 17, is about 822.47. And what that's referring to, that slope, is essentially saying that the city is getting bigger by approximately 822.47 people per year. So it's growing by about 822.47 people per year is what this model is saying. So that's the slope. And then it's also saying when we started at 2005, this was the population. Now, the last question says, using this model, in what year would you expect the population to be 50,000? So you type in 50,000, and then you'd set that equal to 13,982 over 17 times t plus 20,132. You would subtract 20,132 from both sides. That gives 29,868 is equal to this fraction times t. And then you'd divide by that fraction, or in other words, you'd multiply by the reciprocal. So you'd multiply by 17 over 13,982. This gives me a t value of 36.31, roughly. Remember, that is years after 2005. So sometime in the year 2041, or again, if people were just asking for the output, the year would be 2041.31. If they're just asking for what the output of the function gives us. Hopefully that all makes sense. Obviously, in my class, I'll tell you how to write the answer, whether to write 2041 or 2041.31. I'll tell you whether or not to round the population to the nearest whole number or to 2 decimal places like we did here. And in the previous ones, when we talk about here, I'll say, yeah, make logical sense, or round to the nearest whole number, or round to 2 decimal places in those cases. Let's do another type of word problem. Example 5 says, a salesperson is hired at a company. The salesperson is given 2 options for compensation plans. Option A is a base salary of $50,000 plus 10% commission on sales. Option B is a base salary of $75,000 plus 5% commission on sales. Write equations for the total pay in both scenarios if the salesperson has S in sales. So we're going to have two different linear equations here, one for option A and one for option B. Once we create those, then we'll say what is the pay for each option if the salesperson has 200,000 in sales. So if there's $200,000 in sales, what's the pay for each option? And then how much does the salesperson need to sell until the two plans are the same? If you want to try this on your own, go ahead and push pause on the video and do this on your own. In a couple of seconds, I will show you how it's done. All right. In this one, the two equations are pretty straightforward because the salary is going to be a fixed 50,000 plus 10% of sales on option A. On option B, it's going to be a fixed 75,000 plus 5% on sales. So all we have to do, let's do this for option A. For option A, the total pay is going to be just what it sounds like, 50,000 plus 10% of sales. Be careful when you do 10% of sales. I know we've dealt with percentages before. Sure you all have. 10% is 0.10 times S. So 10% of sales is 0.10 times S. Now option B is very similar. The pay is going to be a higher fixed cost, but a lower percentage on sales. So option A has a lower fixed salary, but a higher percentage on sales. Option B has a higher fixed part of the salary and a lower percentage on the sales. So these are my two equations for pay in each option. Then it asks, what's the payment if the salesperson, if there is 200,000 in sales? So if the salesperson sells $200,000, what happens with option A? Well, for option A, if the salesperson has $200,000 in sales, they would take 50,000 plus 10% of that 200,000. 50,000 plus 10% of 200,000 is 70,000. So the pay is 70,000 if the salesperson sells 200,000. In option B, if the salesperson sells $200,000 worth of stuff, option B would take 75,000 and then tack on 5% of the 200,000. When we calculate that, the payment would be 85,000. So if the salesperson sold 200,000, then option B would be a better pay. Obviously, at certain values, at a certain point in time, option A is going to overtake option B. This says how much does the salesperson need to sell until the two plans are the same. So when is that point where option A becomes better than option B? It's not at 200,000. In 200,000, option B is still better. But at some point, option A will become better. How much do you need to sell until option A becomes better than option B? The way you do this is you simply take both equations. Let me take both equations and set the outputs equal. So we'd say 50,000 plus 0.10s, 10s, is equal to 75,000 plus 0.05 times s. That is when the payments are going to be the same. And we can solve that equation fairly easily. Subtract 50,000 from both sides. And then subtract 0.05s from both sides. When you do those two operations, you get 0.05s is equal to 25,000. Now divide both sides by 0.05. What you'll get is S is equal to 500,000. So the plans are equal. When we have $500,000 in sales. And by the way, once this salesperson sells more than 500,000, then they would be making more money in option A than in option B. Option B starts out making more, then they match up at 500,000, and then option A makes more than option B when there's more than 500,000 in sales. If a employee were given these two options, if the employee thinks they're going to sell less than 500,000, then they should take option B. If the employee thinks they'd sell more than 500,000, then they should take option A. In that example, we did a comparison of our two linear equations, essentially. In the previous four examples, what we did is we created a single linear equation and then used it. In example 5, we created two linear equations and then we compared at different values. So that is the case for this section. In this section, all of our word problems were ones where the equation is linear. And if you see another section called mathematical modeling with linear equations, that's exactly what we did here. Hopefully, all of that makes sense. So that's how you can do word problems or application problems using linear equations. And that's the end of this video.